Good, I'm excited. Well done, guys. Right, everybody, can you write Unit 4 or Chapter 4 and say magnetism? I'll give you some work at the end of the lesson, so make sure you're all uh, doing with me, writing with me. This is 11 June. So let's put some things. What you should always do in after every lesson is you submit the notes. You submit your notes because I know your teachers check your notes because they have you in person. I don't get to see you in person, so I can't move around and check the notes and stuff. But I also want to check notes, okay? Because the notes I'm giving you are exam specific. I can't trust any of you to say you have the notes. Okay, wait, let me say. I can't trust any of you to say you have the notes. So you just have to, in these quick lessons that we're doing for the next 3 months, as I'm trying to quickly cover all the content, do the notes with me. You're not allowed to fold your hands. What's going on? Somebody's making noise. You're not allowed to fold your hands. You write the notes with the rest of the class. Everybody. And when I say everyone, I mean everyone. Whether you have them or you don't have them, write the notes that I'm giving you. My version of the notes. We're going to use them for the past papers. Yes. LGK, you can ask your question. Well, you add by writing on a excuse me. You add by writing on a separate separate place, and you submit. So when I'm teaching, just write with me. Just write with me, and then yeah, you have them as the addition. Good. Let's get to work. Right, we're doing magnetism, unit 4, and I'm going to quickly go through this. Um, I mean, I want to summarize. Physics is a subject I really, really love. I mean, I love a lot of subjects, but then I'm going to overcome that temptation, just like I was doing for unit 6. I had a strong temptation to explain, but there's a job to be done, so let's move. I will explain, especially when we're summarizing and when we're doing past paper questions. So I should make sure everybody has resources. So I'll explain only a little bit. Only a little bit. Mostly what we're doing is going through the content together. Make sure you have everything you need. Are you ready? So today what we're going to do is talk about magnetism. It's going to just talk about magnetism, magnetism, magnetism. We know that unit 4 has 3 parts. We are doing part 2. Everybody knows, I've told you, for you to say you are a guru at unit 4, you should know electricity. And when you know electricity, it means you understand the definitions of things, and then you know circuits. Circuits use Ohm's law. We'll practice. I'll practice, and I'll be on you guys 24/7. You have to give me 100%. So I'm going to force you to use Ohm's law. I know people don't like using it. You have to use it. After electricity, we do magnetism, which is what we are doing today. Things to do with magnetism, everything. And then we do electromagnetism. So I just have to do a little bit of magnetism so that you can understand electromagnetism, where you'll be now dealing with the generator and the motor and everything. So let's start. Say magnetism, okay? Say magnetism. That is what we are going through. Magnetism. This is the second part of chapter 4. We are doing magnetism, the second part of chapter 4. Right, let's quickly go through it. What is magnetism? When we say we are studying magnetism, we are studying the force that magnets have. Magnets have a force, and that force does not attract all the time or repel all the time. It can do both. The force on a magnet can pull things or can push things. So I want you to say magnetism is the force produced by magnets. The study of the force produced by magnets. Okay? And you can say that can attract. You are showing that you know that it can attract or repel other magnets. I hope I finish everything. I have a lot. Other magnets and magnetic materials. I want to finish. So I'll try. I don't have time. So when you're studying with a magnet, you should know that a magnet, okay, a magnet has two ends called a magnet has two ends that we call poles. The center of a magnet is not a pole. What we call a pole is the section at the end of the magnet. This is just the center. The end of the magnet is what we call poles. So these two are poles. The ends of a magnet are called poles. One will be north, the other one will be south. It doesn't matter. It doesn't matter which one is north, which one is south. Are we together? What you must know is that magnetic forces are strongest at the poles. Magnetic forces are strongest at the ends. The center of a magnet, right at the center, there is zero magnetism. When you start going towards the end, the magnet gets stronger. Whether it's the North Pole or South Pole, it doesn't matter. But the ends of the magnet, which is these sections, I've shown you that it will be a section like this. North Pole, South Pole, it's just an end, not the whole thing. Okay? Now, the law of magnetism is this. Law of magnetism states that, don't say anything that has not been said. Everything you are taking in right now is just what we have said. One side of the magnet will be the North Pole, the other one will be the South Pole. Poles are at the ends. This is where the magnetic forces are strongest. At the center, there is no magnetism right at the center of your bar. This, what I've shown you, is called a bar magnet. It's called a bar magnet. It's a magnet that's a bar. So as we call it a bar magnet. There's another type of a magnet which we call an electromagnet, which is a magnet made by electricity. That's different. This is a bar magnet. What you must know, the law of magnetism states that like poles repel and unlike poles attract. In other words, when you bring one magnet close to another magnet, it will be all about what poles are coming towards each other. If you have a bar magnet and it is north and south, and it comes close to another bar magnet which is south and north, what you will have is you will have a south pole close to a south pole, so they will repel. Like poles repel. Like charges for electricity repel. So like poles repel. North and north repel. South and south repel. South meets north, they will attract. So these ones will push each other away. You try to bring these two magnets, you see them go whoo, whoo, push each other away. What is going on? It's because you are bringing them at the wrong orientation. The same poles are facing each other. You have to spin those magnets, then you will see them attract. Are we together? So in here, you can see that the magnets, these two magnets, push away from each other. Have you seen that? Because like poles are facing each other. Okay? Students, are we together? This is repulsion. When south meets south or north faces north. Okay? But if you bring south north with another magnet which is exactly the same, then you will see them attract. They'll pull each other close by. Why? These are opposite poles, so they attract. So in here you can say the magnets pull towards each other. The two magnets pull towards each other. We move on. Next thing. The magnetic force that acts between magnets is a non-contact force. In brackets you say it acts without touching. When we say without touching, it means the two things are not in contact. Okay? The two things, the two objects, the two magnets are not in contact. Do you understand? Are these two magnets in contact with each other? No. So, but how are they pulling each other and pushing each other? There is a non-contact force called the magnetic force. What about electrical force? Non-contact. What about force of gravity? Non-contact. You don't have to be in contact with the earth. The earth will pull you down from the sky. How? It's a non-contact force. Are we together? So this magnetic attraction and repulsion, this magnetic force is a non-contact force. Are we together? Now, let's go to the next thing now. We've studied about magnets. Let's go to the next thing, which is the uses of the magnets. The syllabus expects you to know that. Uses of magnets. Okay? Okay? Right to say. There are two types of magnets used everywhere in daily life. Two types of magnets used everywhere in daily life. One is the permanent magnet. Permanent magnet. Permanent magnet. It's something that when it becomes magnetic, it will forever be a magnet. We're going to see a magnet which can be made a magnet and you can switch it off, which means it will no longer be a magnet. This one cannot switch off. Once you make a magnet with this one, it will forever be a magnet. Those ones where you go to the shop and you buy them and they are magnets and they'll forever be magnet. That's a permanent magnet. So, permanent magnet, yes. A permanent magnet, before we talk about its uses, permanent magnet keeps its magnetism without needing electricity. A permanent magnet keeps its magnetism without needing electricity. You're going to study the second type of a magnet that needs electricity to work, but not the permanent magnet. Okay, it keeps its magnetism. It will forever be a magnet. Where do we use such uses of permanent magnets? Uses of permanent magnets. I want you to say here use, then you say purpose or reason. Uses of permanent. One is a compass. Two, it's in school experiments. School experiments. Permanent magnet is used as a compass for direction. Okay, so the reason is for navigation, to know where you are going. If you are in a ship, for it to know where it's going, whatever, it needs a compass. Are we going southeast or northeast or what? You need a compass for navigation. School experiments, you need a permanent magnet for demonstrations. You don't need a magnet that needs electricity. No, you need a magnet that will always be a magnet. So for demonstrations, schools use permanent magnets. Then toy trains. Then fridge magnets. Do you know fridge magnets? If you want to stick things onto your fridge is like this. You want to stick things on a door, you bring a paper, then you put a magnet on the paper. So you'll be now reading the things that will be stuck on the door of the fridge. If it's a recipe or whatever rules, those are stuck by a fridge magnet, and it's a permanent magnet. It is used to attach items to fridges. Then another use of permanent magnets is to connect the carriages. You have a big train that runs on railways. It's a toy. Then to connect the carriages, it uses permanent magnets. So these are just some basic uses of permanent magnets. Nothing is complicated here. So remember, there are two types of magnets. There's a magnet that doesn't need electricity to be a magnet. It will forever be a magnet. That will be a permanent. It keeps its magnetism, if we say it that way. A magnet that keeps its magnetism is a permanent magnet. Are we together? Students? Then we look at the second. It's called electromagnet. Electromagnet. Now, these ones don't keep their magnetism. They are not always magnets. Okay. Electromagnets, we can call them temporary magnets. You can turn them on and off. Really? Yes. An electromagnet, you can write to say, an electromagnet only becomes magnetic when an electric current, when electricity flows through it, or when an electric current flows through it. That's an electromagnet. Sorry. Give me a second. I need to add somebody who's trying to join. LGK, do you learn with Mbaki? All right, so this is a temporary. Everybody, wake up. Electromagnets are temporary. We switch them on and off. The reason why they only become magnetic when electricity is flowing is we can switch off electricity. So this magnet, we can switch it on and off. When we switch on electricity, it becomes a normal magnet. When we switch off electricity, it will stop. Let me just teach you then I'll explain. You see, in countries where they pick scrap, pick scrap and recycle and stuff, they'll be having a machine like this. So this machine has a big arm, like that. What it does is it goes to the scrap yard and it goes where there are a lot of metals. TP. It goes to the scrap yards where there are a lot of metals. And guess what? They would have switched off the magnet. They put it on top and switch on the magnet. When they switch on the magnet, all the TPs come, all the metals, they get stuck on the head. This is where they switch it on. It takes all the metals, then it will move with them, take them to a new place where they are collected, then it will switch off. Then all the metals will fall in. All the metals will fall in. So this magnet, they can switch it on to pick up all the metals from the scrap yard. Then they take it to where they want to throw it away. They switch it off. All the metals will fall down. Are we together? Are we together? Exactly. This is a temporary magnet which is made by electricity. So what do we use this one for now? We've seen permanent. Permanent, we use it for sticking things on the refrigerator, right? Permanent, we use it for navigation. Permanent, we use it for experiments. Permanent, we use it for toys. Don't say, toys are not important. Well, for children, they are. So these permanent magnets are used for that. Temporary or electromagnets, what are they used for? These ones are used for, let's put their uses. Uses of electromagnets. Uses of electromagnets will be, I want you to say use, then you say how magnetism helps. You say use, then you say how magnetism helps. Use number one. You can say reason. Use number one is in MR. Try to make it thicker. This one, because some uses are a few words. We use them in MRI scanners. When you get to A level, you will be asked to say how this MRI works. It's part of the things that you know at A2 level, which is the second year of your A levels. For those that will try it in a year, it's yes, the last part of A level. You need to know how MRI scanners work. These are used to produce images of the inside of a person. So to produce medical images, we use these electromagnets. Are you telling me? Yes. They are used in speakers. Really? Yes. To produce sound. To produce sound. So speakers have magnets. Yes, you know that speakers have magnets, right? Everybody knows that. Speakers have magnets. Those magnets are electromagnets. So we use them in speakers, not only speakers, earphones, not only earphones, microphones as well. All these three have electromagnets. Magnets that are made to be magnets by an electric current. This is to produce sound. In an earphone, they also produce sound just like a speaker. Then in a microphone, they detect sound. So we are not asking you to know how this happens. We are just asking you to know what we use them for. Don't worry about how that happens. You should just know. And I said you use them in recycling. I kind of showed you. In recycling plants. To do what? To pick steel or to separate metals. So you can say to separate steel from waste. Okay? And also in trains. And also in cranes. So I want you to say scrap metal cranes, which are cranes that lift scrap metal. Okay? They lift heavy scrap metal and they take it somewhere else. So you just turn it on, then it will make all the metals fly and stick onto it. Then you move, then you turn it off. Are we together? The last use, which you are supposed to know a little bit about, is what we call magnetic levitation trains. Maglev trains. Okay? Levitate above tracks. They are used in trains. There we go. Wow. These are all uses. Surely these are the easy things. We didn't ask you to explain how. Just know the uses of electromagnets. If they ask you in the exam, write this and move on. Write the uses. Speakers, earphones, microphones, recycling plants, magnetic levitation trains, MRI scanners. All these things use electromagnets. Are we together? Okay. We are moving very well. What time is it? What time is it? Is it timer? Let's do this as the last thing. What time is it? Ooh, we are very late. Wow. Magnetic materials, last thing. I won't finish. Magnetic materials Don't confuse this with a magnet. That's the reason we are telling you this. And you're going to have to know, oh, sir, I'm too young to know that. No, you're not. You have to know it. The syllabus wants you to know it, so you have to know it. I'll tell you the difference between this and a magnet. Only a few metals are magnetic. And this will help you to understand. So, when we say something it is magnetic, it means attracted to magnets. So, only a few metals are actually attracted to magnets. If you bring your big magnet on top of aluminium, it's not going to move. On top of copper, it's not going to move. On top of zinc, it's not going to move. On top of gold, it's not going to move. On top of magnesium, it's not going to move. Are these things metals? Yes. Are they metals? Yes. So why is it that they are not being attracted to the magnet? Because they are non-magnetic materials. So only a few metals are magnetic, which means attracted to metals. Okay? And let's put them. Examples of magnetic metals. One, iron. Two, cobalt. And three, nickel. So iron, cobalt, nickel. And you can put steel. Okay? Steel, it contains iron. So that's why it's magnetic. These are the magnetic metals. Are you seeing them? ICN. Iron, cobalt, nickel. Okay? Most metals are regarded, or you can say referred to, as non-magnetic materials. Most metals are in a group which we call non-magnetic materials, which means these are not attracted to magnets. Most metals are non-magnetic materials, which means they are not attracted to magnets. Why do you keep using the word attracted? Don't magnetic materials repel? No, they will never. They are always attracted. Only the magnetic materials. Non-magnetic materials, we can put examples. Examples of non-magnetic metals. Aluminium, one, aluminium. Two, copper. Three, zinc. Four, silver. Five, gold. Six, magnesium. So these are non-magnetic materials, which means these are not attracted to magnets. Yes, This was right now we are going into chemistry. So can you all write? These are not attracted to magnets. So you must know, without a shadow of a doubt, magnetic materials, uses of magnets, and everything. Of course, now we're going to look at the types of magnets, what is a permanent versus an induced. We're going to look at um, uh, identifying materials so that you can tell, okay? So that you can tell if it's magnetic or not. All these things, we're going to talk about a few more things, and then you'll be done. Are we together? Did you see this? Did you see this, everybody? Okay. Magnetic field lines and how to put them. I'll teach you all that in our next lesson. And we'll be done with magnetism. We'll go to electromagnetism and we'll move. Right. Wait, everybody.